Section 2.1, defining average and instantaneous rates of change at a point. Everything about calculus builds off of what we're going to talk about right now. It is the instantaneous rate of change. We have done average rates of change in previous classes, but calculus opens up something where we call the instantaneous rate of change. Now, the average rate of change deals with slope. M equals y2 minus y1 over x2 minus x1. That is slope. All right, and here are two other formulas for slope. You could think of it as these two. It's the difference, they're called the difference quotient, and slope is found over an interval. All right, so when we do slope, we do it over interval. The interval for this one is x1 to x2. All right, what that means is this values are the interval of the slope. So all slopes have an interval. For instance, this blue dotted parabola, dashed parabola, has an average rate of change, if you look at it carefully, from 1 to 5 is this green line. The green line is the average rate of change on the interval 1 to 5. 1 to 5. So if we want to find the slope, we could plug in 1 to the function, 5 to the function, use this, and we get the slope, or the average rate of change of the function on the interval. We could also find the average rate of change from 1 to 3, and that would be these two dots, which is the purple line. All right, but what would happen if this dot got closer and closer and closer and closer to 1? All right, what would happen if these two dots, here we're getting closer and closer, when you get closer to this red line called the tangent line? Okay, it's the instantaneous rate of change. And so what's going to happen is we are going to think, okay, what happens if x1 is the same value as x2, meaning there's a slope of 1 point. There's no interval size. The interval is 0. Well, you can't divide by 0. You can't divide by 0, which there's an issue with that. That's why it's called an average rate of change. Well, the instantaneous rate of change allows us to divide by 0. What if that bottom value, the x2 minus x1, in the bottom is approaching 0? And a limit allows you to see what do you get as you approach 0 on the denominator. So all we're doing is taking the limit of the slope formula. It's just these are the two formulas we're using for calculus. And that gives us the instantaneous rate of change. You're dividing by 0. Basically, calculus allows you to divide by 0 and see what's happening if you were to divide by 0. And this application is called the instantaneous rate of change, which is the slope at any given point. And so if I want the slope at 1, that is this notation, the limit of the slope, and the notation for it is f prime a. This is the notation, one notation. There's several notations for it, and it's called the derivative. We call it the derivative. But yeah, so the limit of slope is the instantaneous rate of change as the interval approaches 0 wide. So let me kind of describe what these notations now are saying. You might like, how does this slope, how does that work? Well, let's talk about this. If I were to claim this dot right here, and I call that, I know it's at 1, but let's call it at a. If the output of this would be f of a. So if we have a value a, and then we plug it into f, because we call the function, let's call this function f, that would be a f of a. All right, and then let's think about this. So if this dot right here, let's call that dot, that would be x f of x. All right, so if we think about that, so if this is a f of a, this would be x f of x. All right, so forgot my parenthesis. Now, if you think of slope here, isn't this really just y2 minus y1 over x2 minus x1? It's just slope. It's the same thing. It's just we're giving them a different notation. All right, so this is your starting value, this is your ending value. You have to do them in letters, and that's all it is. It's the same as this. Now, how about this one? What is this saying? Okay, it's a little bit trickier. Well, you still have, this a plus h and a, what? So you have f of a, right here, and this is a plus h, what? Well, what the h stands for, h is the interval size. So how big is the interval size? So how far over or did we go to plug in x? So what this is saying is this a plus an h interval size. So if this interval size is approaching 0, want to just be f of a minus f of a, which is h is 0. So our goal is, that's why this limit comes into play, is you're trying to find h, or the interval size of 0. Thus creating this dot to be right on top of that dot, thus creating the tangent line. But you can't divide by 0 without the limit. The limit allows you to think of what happens with that. So again, the h is the interval size, so f of a plus the interval size would give you another dot. So in this situation, since the interval is too wide, this would be f of a plus 2, which would be, in this situation, 1. 1 plus 2 is 3, so it's 3. It's kind of tricky, but this h stands for the interval size, so you're adding the size of the interval to the a value you're going to plug in, and then but basically they're the same slope formulas. And then here are the limit formulas using these slope formulas. So again, average rate of change is what we've been doing forever, but calculus allows us to do the instantaneous rate of change because it allows us to divide by 0, or understand what's happening as you divide by 0. And then you have instantaneous graph rates of change, and it's called the derivative. And we use one of these notations is as follows.